Student, in this session we are going to discuss the next point, the equations of motion. The Newton studied the three equations of motion by relative concept of displacement, velocity, acceleration and time, object moving with a straight line. See, suppose an object is in motion along a straight line with initial velocity u. It attains a final velocity v in time t due to the acceleration a. The displacement is s. The three equations of motions can be written as by using the graphical method. He described the three equations. The first equation is the relationship between velocity and time, that is v is equal to u plus at. The second is the relationship between the displacement and time, that is s is equal to ut plus half of at square. The third one is the relationship between the displacement and velocity, that is v square is equal to u square plus 2as. Now let us try to obtain this equation by using the graphical method. The first relation is between velocity and time by using a graph. The figure 1.9 shows the changes in velocity with the time of uniform accelerated. Object is accelerated uniformly. The object starts moving from the point D and reaches to the point B with initial velocity u, and it keeps increasing and reach to the point B at time t. See the initial velocity. OD is the initial velocity, that is u. OC is the final velocity, that is v, and OE is a time taken, and that is t. All of you know that acceleration is equal to change in velocity divided by time. The change in velocity, final velocity minus initial velocity, that is u minus v. U is OD and v is v is u is OD and O C is v, that is u minus v minus u, that is OC minus OD. OC minus OD is equal to CD from the graph. See here, OC minus OD, that is CD. Now next, that is we know that CD is equal to AT square. A is the acceleration, when T is get multiplied by that side, that CD is equal to AT. This is equation first. Now come next one. Now draw a line parallel to the y-axis. Draw a line parallel to the y-axis and passing through the point E, and draw another line parallel to the x-axis through the point D. This will cross the line BE. This will cross the line BE at point A. Now from the graph, see, BE is equal to AB plus AE. See here. Then therefore V is equal to CD plus OD, where AB is equal to CD and AE is equal to OD. See, there CD is already we have calculated in the equation. CD is equal to AT and OD is a initial velocity. See here, OD is initial velocity. Now from the equation we get V is equal to A plus AT plus U. Therefore V is equal to U plus AT. This is the first equation of motion. Now let us solve the next that equation describing the relationship between the displacement and time by using a same graph. See, let us suppose that an object in a uniform acceleration and it has covered the distance s with the time t. From the graph 1.9, the distance covered by an object during the time t is given by area of quadrangle. See, area of quadrangle DOAB. See, DOAB. DOAB. Therefore, the area of quadrangle is equal to area of rectangle DOEA plus area of triangle DAAB. Now calculate the area, that is length into breadth, half of length into breadth of area of triangle. They put the values AE is equal to OV. See here, AE and OE, half of AB into DE, that is the area of triangle. By putting the values there, we know that A is equal to, first is a, here A is a, then OD is the initial velocity, then A is here initial velocity U, and OE is a time. OE is a T and OE is equal to DE. Therefore, DA is equal to time. Then put the values from the equation 1. AB is equal to AT. Therefore, AB is equal to CD. Then from equation 1, we get the equation S is equal to U into T, half of AT into T, that is S is equal to UT plus half of AT square. This is the equations, Newton's second equation of motion. Now let the third equation describing the relationship between displacement and velocity. We have seen that from the graph in the figure 9 point, we can determine the distance covered by an object in the time t from area of quadrangle DOAB. See, area of quadrangle DOAB, and DOAB is a trapezium. So, we can use the formula for its area DOAB. DOAB by using a trapezium formula. Half of sum of the length of parallel sides and distance between the parallel sides. The length of parallel sides S is equal to OD. See, OD and plus BE and into OE. But OD is equal to U, BE is equal to VE, and OE is equal to T. By putting the values of this, we get the equation like this. The CS is equal to half of U plus V into T. We know that A is equal to, but A is equal to V minus U divided by T. That is, acceleration is equal to V minus U divided by T. Therefore, T is equal to V minus U divided by A. This is equation second. By putting the equations, these two equations, S is equal to half of U plus V minus multiplied by V minus U divided by A, we get S is equal to U plus V plus U, V minus U divided by 2A. Here 2A is get multiplied by to the S, that is 2AS, that is V square A plus B square formula. A square minus B square is equal to A plus B, A minus by C, V square plus V U square plus 2S. This is the Newton's third equation of motion. See, always remember, the velocity of accelerated object changes with time. Change in velocity can be due to the change in direction of magnitude of an velocity or both. So this is very important point of your examination. See, these three equations can be asked for your examinations, and by using these equation we can solve the problems also. Thank you, students.